Okay, in this lesson we're going to look at triangle sum properties, so just some basic information about triangles. First, here's some definitions. So, scalene triangle, isosceles triangle, and equilateral triangle. Now you may remember these from before. All of these look at the triangle sides to classify or to categorize them. So scalene triangle, here's our example for scalene. None of the sides are congruent. With isosceles, two of the sides are congruent, and with equilateral, they're all congruent. One of the things I want you to focus on here is that it says no sides, two sides, all sides. Those are really our only possibilities. So we're all set with those. So if it asks to classify by sides, these are your choices. Now remember, if it asks to classify by something else, you have different choices, because with triangles we have sides and we also have angles. So classifying triangles by angles. Again, you've probably seen all these before, but we need to really understand them so we can start talking about different properties of triangles. First we have acute. All the angles are acute. Right triangle, one angle is right. Obtuse, one angle is obtuse. And equiangular, all angles are congruent. So focus, one of the things I want you to notice here, acute triangles, all the angles are congruent. Right triangle, one angle is right. Obtuse triangle, one angle is obtuse. So we're going to talk about that in class tomorrow. So between now and then, I want you to think about, because we're going to talk about it, why acute has all angles congruent, and right, you can only have one of them, one right angle or one obtuse triangle. Okay, angles of a triangle. When the sides of a polygon are extended, the other angles are formed. The other angles are interior angles. The angles that form linear pairs with the interior angles are exterior. So just like we talked about in a different section in a different chapter, interior means inside, exterior means outside. So copy those down. Now here's why you need to understand those definitions. Triangle sum theorem. Again, this is something you've probably learned already. The sum of the measures of the interior angles of a triangle is 180 degrees. You've probably learned that. This, however, might be new. The measure of the exterior angle of a triangle, so I'm going to underline these as I write my equation in this problem. So the exterior angle in this picture is x. So x is equal to the sum of the measures of the two non-adjacent interior angles. So sum of two angles, so I have something plus something else. The two non-adjacent means it doesn't touch it. So these are the two non-adjacent angles. So x is equal to 45 plus 55. So x is equal to 100. Now you could have done that a little differently. You very easily could have said, okay, well I'm going to erase this so you can see what's going on. Instead of that, I could have said, oh, I'm going to take these two and add them together, which I did, so you know the sum is already 100. And then this angle right here, because the angles of a triangle add up to 180, has to be 80, and then these two angles have to add up to 180. So 180 minus 80 gives me 100. Now that's the same concept, it's a longer way to do it. In fact, using that process, you would be able to prove why we did what we just did. Okay, now a couple examples to finish up with. Find the measures of the angles BAC and BCA. So BAC, I want to know this angle measure, and BCA, I want to know this angle measure. Now, to be able to find either one of those, I notice the angles add up to 180. I've already used 90 of it. I've used 90 here. So the two acute angles have to add up to 90. So my equation would be 4x plus 3x, which is 7x, 11 plus negative 5, or plus 6. Those need to add up to 90. So if I subtract 6, I have 7x is equal to 84, and x is equal to 12. But the question doesn't ask me what is x. The question says, what is the measure of each one of those angles? So I'd have to go back and substitute that in. So for angle BAC right here, 3x plus 11, I'd have 3 times 12 plus 11. Well, 3 times 12 is 36. 36 plus 11 gives me 47, so that's 47 degrees. And then for the other angle, I'd have 4 times 12 minus 5. Well, 4 times 12 is 48. 48 minus 5 is 43. So there's that angle. And those two together should add up to 90, which they do. Okay, in this last example, we're going to go back to that exterior angle theorem, because that's all I can use here. So here's my exterior angle, 5x minus 2, equals the sum of the two inside that don't touch it, 2x plus 76. So I'm going to subtract 2x and I get 3x. I'm going to add 2 and I get 78. X is equal to, 3 goes into 7 twice with 1 left over, 3 goes into 18, 6. So x is 26. Again, I need these angle measures. So angle ABC is the easier one. 2 times x is 52 degrees. 2 times 26, so I've got that one. Then for the other angle, I have to take 5 times 26, so 26 times 5 is 30, 10, 13. So I have 130 minus 2, which gives me 128 for angle BCD. So again, I should be able to take 52 and 76 and add those together and get the exterior angle, which is 28. And I did. So that's it. Hope that helps. Thanks for watching.